All right, thumbs up. Can everyone hear me? Yep. Okay, cool. I'm softer than Dan, which makes me like everyone that's not Dan. And I also talk kind of fast, so if you have trouble, like just wave or something, and I'll loop back. So yeah, I'm talking about some operational stuff. My name is Chris. I'm a senior engineer at NodeSource. I'm also the last thing between everyone and beer, I know. So I'm going to try and get through this expeditiously. Like I said, I'm a senior engineer at NodeSource. Worked at Media Temple for literally ever. I thought I saw some hoodies. Did you guys just move like here?
We're downstairs.
Seriously?
Yeah, we're on the floor.
Wow. When we moved into Hayden, and the whole company was like 30 people, we were like, we will never need another office. We can all just live here. It's fine. It's crazy. Anyway, hi Media Temple people. I'm old, 41. They said I was senior engineer one day, and I didn't know if that was age or ability, and I didn't ask. So, but at this point, I've coded in kind of everything. But these days, I do more ops work. I'm on the infrastructure team at NodeSource. So what I'm going to be talking about here is really nothing about writing Node code. It's much more about running Node code. It's kind of a big topic, but we'll go through how to get Node on your systems, like your real systems. We'll talk about security a little bit. We'll talk about performance a little bit, and some licensing stuff. So just some stuff. Basically, this is my idea that was like, okay, if I was like, mentoring like a young like small startup, and they were like, okay, we're going to AWS, like, people are going to see it. What do we need to do? This is kind of what I would tell them. If you already know all this stuff, like I said, we'll get to beer quick. So installation and updating. The reason I'm at NodeSource is because a really long time ago, I started publishing Node packages on Launchpad for Ubuntu because the distros don't update, and Node was updating super quickly. And now it's resulted in me like working at NodeSource full time, and I do all this stuff under the NodeSource banner. But there's a couple of different ways to get Node onto your system. One is to go to nodejs.org and download stuff, but in a production running, real world system, you're probably not going to do that. What I strongly recommend that you use instead is the NodeSource repositories. We try and support every major vendor-supported Linux distribution that we can. There's a couple we can't do. We don't support Red Hat 5 on anything newer than 0.10, which is thankfully going to be end of life in like 3 days. We only support 64-bit CentOS or Red Hat 6 because we kind of have to for a technical reason. And outside of that, we're pretty much good. Node 7 just came out, and we dropped support for Ubuntu Precise and Debian and Wheezy, which are also super ancient at this point. But the point is, if you're running anything even kind of modern, you should be just fine. We recommend using LTS stuff, obviously, in production. You have 2 LTS versions to pick from these days. There's 4 and version 6 just went LTS. For those that maybe are a little newer, if an LTS or long-term support milestone has been reached for release, what the Node Foundation promises you is that they are not going to break any APIs out from under you. So if you're working on version 6 point anything at this point, you should update to the newest thing whenever it comes out, because it may be security or maybe performance, but your code should not break. That is the LTS promise that we have for you. If you want even more bleeding edge, version 7 is out now, and it's not LTS, which means, new shiny stuff, but things may change. But if you just go here to the GitHub page, you can see how to install these things, and you can use them on your system in the way they're used to, which means if you're like on a Fedora system, you can type yum update or dnf update. And if there's anything new, you will get that, which is important because of security. So Dan mentioned this because Dan and I did not cross-reference our slides, which we should do next time, buddy. Yeah. Node.js itself is, could have security flaws, but it also bundles several other libraries. This, by the way, is one of the critical differences between the Node packages that we make and the Node packages that your Linux distribution came with. So we do what the vanilla Node the Node Foundation recommends, and we bundle all these libraries in, that includes OpenSSL. Roughly every quarter, OpenSSL will have a massive CVE explosion, and everything will have to get updated, which means that if you're running these things, you are instantly insecure, which is, again, why if you're running an LTS, you should always be using whatever the newest thing is. We at NodeSource obviously are very in tune with all that, so we get these packages built very, very quickly after the official source releases come out. And if you get on one of our distributions, you will just get fed these things automatically. So if you have a reasonable update cycle for your machines, you're just going to stay safe, both from a security standpoint and periodically if they have like some significant performance and improvement, it doesn't break an API and that'll go in or what have you. Like I said, LTS updates should be safe, but if you can test things first, go ahead. I honestly have really never seen anyone have problems as long as things were in the LTS zone. Other things that can cause trouble or interest or operational complexity is the module ecosystem within the Node community. So NPM, in no way humble opinion, is both the great blessing and the great curse of the ecosystem. It's a massive, massive, massive repository. It is the biggest software packages repository in existence, which is saying something because Debian's been around for a really long time and has a tiny, 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 tiny fraction of the amount of individual packages that NPM does. But of course, that also means you can get completely crushed by choice, right? There is no standard library in Node, something that I personally think is a terrible idea because of the aforementioned being old thing. But you have so much choice, and what are you going to use? And how do you pick what to use in your production application? So there's a couple things that we would recommend that you do before deciding what it is that you're going to use. And they're sort of common sense, but I'm going to go ahead and talk about them here. First of all, check on the license. If you are launching a production thing, you need to make sure that when you npm installed a thing and that thing installed 73 other things, that somewhere hidden in there, there's not a license that is going to screw up your operation. First of all, that means that it may, I don't know, you might need to check that it even has a license. There's a variety of npm modules that will tell you what the licenses of all the other modules are. There's there's a bunch of them that I saw. There's one called licenses. I would definitely pick one and just check and make sure that the stuff you're using is okay if you're running that in production, if you care. But if you have any legal exposure, you probably should. Check it out on GitHub. Is it, if it's a bigger project, is it active? Has anybody committed to it recently? If it's a fairly big thing and no one's touched it in 2 years, that might be a red flag. If it's 6 lines and no one's touched it in 3 years, then it probably doesn't matter because, who cares? But for the important stuff, you want to make sure that there's a community that's active, that it's getting updated, that when the new version of Node comes out and you want to use that and there's some breaking change, somebody's there to compensate that, whatever it is. So things that, along with that, was there a release recently? Are there collaborators on it? Has it been downloaded, right? I mean, if something's been downloaded 500,000 times in the last week, that thing is, probably at a higher confidence level than something that's been downloaded 4 times in the past quarter or whatever, in terms of you're feeling safe about it. Other things to be very aware of, right, is that you're installing a lot of other people's code. This is not specific to NPM at all, but it is something that you need to be aware of. So those modules can have issues. They, like any other piece of software, this could be an exploit that is not something that you wrote, but just something that you got included that you may not even know you have. Because like I said, you npm install, Express, and that's 90 packages or whatever it is these days. So there's Nodesecurity.io that starts to try and keep tracks of these things, and also Sync does that as well. I do work for NodeSource. We are the enterprise Node company. We do, as Dan said, have a commercial software product called NSolid, which is an augmented version of Node. It is Node with more features that are what we found that enterprises are wanting. I'm not up here to give you a sales pitch. But as it turns out, we built this product to address operational complexity concerns that enterprises have. So we do have to at least point out that our NSolid product, if you were to use that, has built-in scanning stuff for you. So we aggregate all this like vulnerability data, and your app will report and say like, hey, I have all these modules, and if we see you're using something that we know is vulnerable, red lights turn on. It's pretty cool. Like I said, not trying to shill, but it would be inappropriate of me to not point out that yes, we do in fact make something to address some of these concerns. And if you want to learn more, just go to nodesource.com, and I will move on. So next thing is how to actually run your code. I think a lot of people, especially in this day, like back in my day when men were men and we wrote our own device drivers for breakfast and blah. Everyone knew how to do this. But now I think there's a lot of people that are very good programmers that know how to run things on their laptop, and then they hand it off to an ops team. But maybe you're at a startup and you don't have an ops team because you're the ops team. So what do you need to do? Well, you're going to have to launch your code somehow, and then you're going to have to restart it if something breaks. And you're going to have to deal with all these things, and you're going to have to deal with crashing. And you're going to have to deal with some state stuff too, because you're going to, I promise you, I don't care how stable your thing is on your laptop, when you put it up in the real world, users will break it somehow. They're amazing. One thing that we see this a lot. We do architecture evaluations for like big, companies that you would think would have like, no, they don't. You get exceptions when you write Node code, and sometimes you can handle them, and sometimes they're just unhandled. They're just uncaught. If you have an uncaught exception and it crashes your process, let that happen. Have something else there to restart your process and put like an on exit, some handler that will log whatever state you think might be responsible. Because if you have an unhandled exception, you don't know what state your app is in. And it is much, much smarter to let it die and start it back up again than to like try and magically put your entire app in a try-catch statement and keep going. Bad things can happen if you do that. And then particularly with respect to security, like I said, you just don't know what the internal state of V8 is at that point, which means that you may think you're writing out like your hello world statement and you're actually writing out a credit card number, to the end user, and that would be bad. So if you have unhandled exceptions, let it crash, and then you should be running it under something that will start it back up, which I'm about to get to. The good news, right, is unlike like a Java app, which could take like literally 10 minutes to actually start, your Node app will probably start up in a trivial amount of time. So, but on that note, with restarting, what should you be doing? How should you be running things? There's a couple of options, right? Some of them are essentially how Linux does things, and some of them are things that Node developers wrote. These are going to be the Linux ones. These are going to be the ones that Node people wrote. These are going to be ones that I would recommend you actually use on production machines. These are going to be the ones that you should do for Java on your laptop. In my opinion, which again is not even remotely humble on this particular topic. A lot of people we've seen do really like using PM2 or Forever or some Node mod in production. The reason that, in my opinion, you should not do that is because Upstart and systemd, which are the Linuxy ways of starting programs, allow other people and other operators and eventually your ops team and whoever to monitor and restart and check on logs and keep track of these processes in the way that they keep track of everything else on your box. Also, the people that wrote these things are people who like interact deeply with the Linux kernel and are very good at starting and restarting processes in production. In particular, systemd. Who knows what systemd is? Okay, decent number of people. You had a hoodie on, so I know you know. So if you don't know what systemd is, it is the new shiny thing in the Linux community that people use to start, stop, restart, control, monitor, do all these things to your program. So if you fire up your Linux box, for example, and you've installed MySQL, and MySQL just turns on when the machine does, systemd was responsible for turning that on, and many, 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 many other things. Lots of people in the Linux community have what I would mildly put as very, very strong, often negative feelings about systemd, because it does a lot, and it does a lot in a place that old school people kind of feel it shouldn't. But that's totally relevant, because that's what's happening now. Every major distribution is using systemd. Red Hat, which is undisputably the big fish in the Linux world, wrote systemd and is backing systemd. Debian and Ubuntu are like it is what's happening, whether you like it or not. It's kind of like the election this year. And it doesn't matter whether you like it or not. Like that's it. That's it. That's what is coming. Upstart is sort of an older thing that is going to get phased out over time, and you're going to have to learn how to use systemd. It is fortunately actually quite nice to use, and it does give you a lot of really cool features. So if you want to learn about it, just check, it's very easy to Google for it. But basically, if you have like an application and you just run in one process, you have one file. It's very simple syntax, and you kind of say start it with these parameters, and it will turn on. And it will restart automatically, and it will take care of your logging for you, and it will do all this other stuff. So that's my little high horse about systemd. And by the way, I'm not trying to knock any of these. They're cool projects. I'm just saying in production, I would do things that everyone else that's operating Linux boxes at scale in production does, which is use the system level tools. From what I can tell, like if you want PM2, like to make sure that like clustering is working on your app on your laptop, awesome, go for it. All right, moving on. Performance. Now, Node makes a lot of really good and often true promises about performance. Like when you force the event loop in front of people, it does give you a certain amount of asynchronous functionality that you kind of almost can't escape, which can be really great for performance. But there are still things that you have to be aware of, and these are things that we've seen talking to bigger companies. It's fast, but certain things, A, can be CPU intensive, and B, can be synchronous and block everything. And it's good to be conscious of what the major ones are. Huge loops. For loops, all used to them, array for each, whatever you want to do. And they're great, but it's easy to get out of control, and all of a sudden you're looping over 500,000 items per run. That can do really bad things, especially if you're looping over objects that are very deep nested objects, that sort of thing. If you realize that you are doing a loop over 6 figures of things, try and ask yourself if you can split up that functionality into smaller stuff. And you may be sitting there going like, that's ridiculous, I would never do that. Good, I'm glad that is true for you. But again, like big companies, that you would think would know better. Nope, totally do this kind of crap all the time. And we get into these arch evals and we're like, really, guys? And they're like, well, what else are you supposed to do? And we're like, literally anything else. Like not that. You can use things like async to help structure, but in general, something architecturally is wrong if you're looping over 6 million things, like in the normal flow of stuff. If that's like an offline, like you're crunching stats thing, then sure, but it's all that's sideband. It's not affecting the performance of your app. But the even bigger one that we see getting people is one no one thinks about, which is just parsing JSON. You don't think about JSON anymore. You're just happy it's not XML. Like, be honest. You're like, we escaped that. JSON's nice. And it is nice. The JSON parser is really slow compared to other things inside of Node. And there's not a whole lot that can be done about that without a lot of really, really gnarly hard work that may happen someday. Slow is a relative thing, right? I mean, it's slow compared to other operations that happen. And if you're parsing, 400 bytes of JSON, then no, it doesn't matter if it's way slower because it's still going to be essentially instantaneous. But if you're regularly parsing like several hundred kilobytes or several megabytes of JSON, yeah, that will block the event loop while it's happening. Other thing, and that you can get loop pressure and things pile up, and it's really, really bad. JSON Stream, which does what you would imagine can help, parses things on the fly instead of having to dump the whole thing in. But you'd really be amazed how many people are trying to regularly parse like 6 megabyte JSON blobs like you literally reading in like a meg of JSON and then trying to parse through it in production. There's a couple reasons it can happen. It's usually laziness. It's kind of like before, you're all like, I would never do that. Great, good, but it does happen. And it can particularly happen, a lot of ORMs don't know how to only return the fields that you care about. They'll just kind of get everything in like a given row. And it's like, you can test it on some small app and then you actually put it in production and you're in, the table you're on has like 73 different rows and you're getting all of them every time. And you only need like 3 things out of it. But all of a sudden, in your head, what you think you're getting across the network is like, you're like, I'm getting 3 8-byte strings. What, no. But no, you're actually getting like hundreds of kilobytes every request, right? And this can really slow things down, and it will make things feel sluggish. And you're like, I'm using Node. The whole point is it doesn't feel sluggish because it's evented. This is just one of the gotchas. So just be aware, how much JSON are you parsing? Is it, is it a blob? Is it going to be a problem? Troubleshooting CPU is actually fairly easy compared to other things. There's a variety of stuff that you can do. If you're using v4 or v6, which you definitely should be at this point, the prof and prof process flags can be of great assistance to you. And in v6, the inspect flag is super cool. Anyone use the inspect flag? Okay, it's really, really cool. This is v6 and up, but you just run your app with that inspect flag, and when it fires up, it will give you this like really crazy looking Chrome DevTools URL, and you can cut and paste that into Chrome on your laptop, and it will like attach itself to the process as a debugger, and you can just like watch everything and keep snapshots and CPU. You can do all this really rad stuff. It's still considered experimental, although it seems, like the times that I've messed with it a little bit, it seemed pretty cool. So. Those will tend to help you track down what's taking up a lot of CPU time very, very quickly. Unsurprisingly, not chilling, have to mention it. Our NSolid product very specifically addresses this, gives you tons of pretty graphs. It even has a thing where you can sort of go like, hey, if this process uses like more than 30% of the available CPU for 10 consecutive seconds, at that moment, take a snapshot and email me to tell me that it happened. And then you can go look at that snapshot, and it will tell you like which line on which file is taking up all the time. Again, we obviously built this because this is the kind of thing that big companies are interested in being able to get to very quickly. Memory leaks, always tricky, especially very tricky with asynchronous anything. And memory in general is just going to be a harder thing to diagnose always than CPU. CPU is really easy because the CPU can tell like exactly what code it was executing at any point, and it's very easy to map that back to the code that you wrote. Whereas, RAM is by definition, it's random access, so it's just this blob of stuff that you have to try and figure out what's going on. So it's kind of tricky. It's not, you don't run into the situation like you do in C or C++ where you can like do weird things where there's just memory in the process that isn't really reclaimed right, but can't really be used again, but it just sort of bloats over time. That can't happen because Node is not Java. Node is garbage collected like Java. But what can happen is, and what usually happens is either something is holding on to file handles. If you're doing file activity, you're not, something's not getting closed, that can cause a problem. Or more likely, if you have long-lived objects and you keep adding things over time, generally slowly, that's where you get this really like scary, like slow creep over time of memory. And that can actually, that is one of the hardest problems that we see for Node developers is, more than a couple, like, big public companies we talk to, they're like, they just have things sort of restart in a no downtime way, like 20 times a day. Happens all the time. It's not great. Again, inspect flag can help you because you can take a heap snapshot. There's a module heap dump that can help you with this. Shockingly, NSolid also helps you do this. Same kind of thing. You can say like, if this process is using more than 20% of the available memory, take a heap snapshot and give it to me. What is typically going to be, if you see this happening in your own app, you see like the resident set size just growing slowly over time. Like look for something that's like is there a server object that is just there for the entire running of of the thing, and are you ever putting anything else into that at any point? If you define a singleton, if you're using a singleton pattern somewhere, right? And you're like, oh, I'm doing sweet computer science stuff, singleton, right? Because you are. You're like, can I get a closure in here somehow? And yeah, and then like there's something that that attaches some like injects some new properties, some other object or augments that singleton object over time. There's just one of them. It's never going away, so it's just going to keep going. Like it's not the only way, but those are the most likely kinds of places where you get these crappy to diagnose memory leaks. Very long-lived objects that have like incrementally things just getting stuffed into them that you're not clearing out in some way. So just keep that in mind as you're developing and you're going through the operational stuff. We are just at the end here. Keep your versions up to date. Again, please use the repositories. They work well. Pay attention to your licenses. Pay attention to security vulnerabilities and for production stuff. Have a restart policy. So use something like systemd that can automatically, if you're, again, unhandled exception, it should crash, it should log something so you can figure it out later, and then something like systemd should start it back up for you. Be aware of CPU and memory stuff. In a properly functioning Node program, where you're not doing like something like rendering, which you shouldn't be doing from Node anyway, Node should not use a lot of CPU. Okay, if you're using a lot of CPU and you're not sure why, something is wrong. It's not supposed to work that way. And keep an eye on memory usage. Like whatever provider you're using will have monitoring tools. Use them and be sure to use them. It's like being sick. Like if you go into the doctor, you really want to make sure that doctor knew what you looked like when you were healthy. Okay. Same thing with your app. Like you want to know what normal looks like so that you know what abnormal looks like. So make sure you have that kind of baseline. Have a look at it, before you get into real trouble. The day will come when you just get a lot of traffic and you're like, yay, and then everything breaks. And you're like, ah, and at that moment, it's good to know what normal looked like before. I think that's it.
So this is the original Node logo. One little detail that I love is Ryan's website. It's still up today. tinyclouds.org. Inside the logo, there's this little tiny cloud, and that turned out to be incredibly prescient because today all of our computing systems are running on the cloud, and increasingly we're running in